Children, in previous video we have studied about some terms related to a wave, right? Vibration, wavelength, amplitude, time period, frequency. So revise it again and again. Now come to the next point. What is audible range, children? Audible range means we have read that all vibrations cause sound, right? But the human ear cannot hear sounds of all frequencies. We can hear sound of frequencies in the range from 20 Hz to 20,000 Hz. We have a range. We can hear sounds of 20 Hz to 20,000 Hz. Hertz Hz is the unit of frequency. So we cannot hear sound of frequency below 20 Hz and above 20,000 Hz, children. We cannot hear below 20 Hz and above 20,000 Hz. The range of frequency from 20 to 20,000 Hz is called audible range. It is called audible range. Okay? But more than means above 20,000 Hz we cannot hear. That is the ultrasonic sound. That is called ultrasonic sound. This is sound of frequency higher than 20,000 Hz. It is called a ultrasonic sound. Higher than, or you can say more than. Okay, higher than 20,000 Hz are called ultrasonic sound. So we cannot hear the ultrasonic sound, children. Our eardrum cannot bear that much frequency of sound. But some animals like dogs, bats, monkeys, deers, leopards, etc. can hear the ultrasound sound. Dogs can hear sound of frequency 50,000 Hz. Bats can hear sounds of frequency 100,000 Hz. Okay. Now question, what is the how bats use of ultrasonic sound? Use of ultrasonic by bats. Okay. How they can use ultrasonic sound? Bats have no eyes, children, but they easily move about without colliding with any object or obstacle, right? So the reason is that they produce ultrasonic sound as they fly. When this ultrasonic sound comes back after reflection from any object or any obstacle in their way, they hear it and thus they detect the presence of the object or obstacle. They can detect and they can catch their prey, or they can catch any kind of obstacle. That is the they produce ultrasonic sounds. Okay, you can their sound produced name is squeaks. It is a very loud sound, children. Ultrasonic sound they produce. Okay, so due to their reflection from any object or obstacle in their way, they hear it and thus they detect the presence of the object or obstacle and aware of it, and they change the direction. Okay, now infrasonic sound or subsonic sound. What is infrasonic sound? Infrasonic sound, or you can say subsonic sound. So the sound of frequency lower than 20,000 Hz. Sorry, 20 Hz, lower than 20 Hz. Lower than 20 Hz. This is called infrasonic sound. We cannot hear the infrasonic sound. For example, the pendulum of a clock makes one vibration in 2 seconds. The frequency of sound produced due to its vibration is 0.5 Hz. It is called infrasonic sound and hence we cannot hear it. So the frequency range of different sounds of different objects. Below 20 Hz, infrasonic. Audible range already taught, that is 20 to 20,000 Hz, that is audible range, and ultrasonic is more than or higher than 20,000 Hz. Okay, children. Now there are the two characteristics of sound. First is loudness. First is loudness, second is pitch. Okay. So what is loudness? First understand, a sound wave is characterized by amplitude and frequency. Okay. Depending upon the amplitude and frequency of the sound wave, we have the following two characteristics. First is loudness, second is pitch. So loudness is what? The loudness of sound depends on the amplitude of vibration of the vibrating body that produces sound. Okay. And some in waveform you can understand clearly. See here, greater the amplitude of vibration, louder is the sound produced. In this figure A and B, you can see figure A, A1 and A2, A1 and A2 here mentioned. A1 is the and A2 is the amplitude. Okay. So this is greater the amplitude of A1 of wave A, the higher is the louder is the sound produced. Therefore the wave B produces a louder sound than wave A, because here is a greater than wave A. This will produce louder sound. Okay. So if you gently pluck the string of a guitar or a sitar, soft or a faint sound is heard. But if you pluck the string hard, it moves more from its rest position. So the amplitude of vibration increases and so loud sound is heard. Okay. Similarly, many examples you can take. If you strike the drum gently, a faint sound is heard. But if you strike it hard, you hear a loud sound. So the loudness is the characteristic of sound which distinguish a loud sound from a faint sound. That is called a loudness. Understood? I hope it is clear to you what is loudness of sound. So loudness is the characteristic of sound which distinguishes a loud sound from a faint sound. Clear? Now the loudness of sound also depends on the area of vibrating body. Greater the area of the vibrating body, louder is the sound produced. You can create sound through the drum. Okay, drum membrane is very tight, children. You can see in school. Just remember school drum. Okay, when drum was beating, that time you can hear a loud sound. So greater the area of vibrating body, louder is the sound produced. If you take two drums, one small and the other big, the beat of them to produce vibration in them, you will notice that the sound produced from the big drum is louder than the small one. Okay. In temples also, you must have noticed that bell in a big case produces a louder sound than that in a small case, right? Must notice. If you did not notice still. Now come to the second characteristic, that is pitch. You see here, pitch diagram is here. Pitch of a sound depends on its frequency, children. Okay. So on the frequency of the vibrating body, a sound of higher frequency is said to have a high pitch, while a sound of low frequency is said to have a low pitch. Okay. Their loudness depends on the amplitude and pitch depends on frequency. High pitch means high frequency, low pitch means low frequency. Okay, you can see here wave with a lower frequency here and wave with a higher frequency. High frequency, high pitch sound. So higher the pitch, shriller is the sound. But if the pitch is low, the sound is flat or a grave. So the voice of a girl's sound is shriller than that of a boy, right? So girl sound is always shriller than a boy because the voice of the girl is of a higher pitch and the comparison to the boy. So voice of a child is shriller than that of an adult. Okay. So pitch is the characteristic of sound which distinguishes a shrill sound from a flat or a grave sound. Clear, children? Now maybe ask question. What is the characteristic of sound which distinguishes two sounds of the same pitch and the same loudness? Same pitch and the same loudness. So how it will happen? First understand this. Two sound of the same loudness and same pitch may differ in quality of waveform. You can see here quality of waveform. This is the quality of waveform A and B. See here this diagram and see here this diagram. So two sound of same loudness and same pitch. Same loudness, same pitch, but differ in quality of wave. See this wave and in this wave. So this is called quality. The quality is the characteristic which distinguish two sounds of the same pitch and same loudness. This will remember, children. This is important. Now speed of sound. What is the speed of sound? Speed of sound you can find out by this formula, distance by time. S by T meter per second. So estimation of speed of a sound in air, you will estimate the speed of sound in air. Suppose we choose two hills A and B about a kilometer apart. A person at the hill A fires a gun. Another person at the hill B starts a stopwatch. As he sees the flash of the wire stops it on hearing the sound. Thus, he measures the time interval between the seeing of flash and hearing of the sound. So, let T be T second and the measure distance between hill A and hill B. So, this is a formula. The speed of sound is distance by time. In this manner, we can solve some questions. A gun is fired in the air at a distance of 660 meter from a person. He hears sound of the gun after 2 seconds. Find the speed of the sound. So, here distance travelled of the sound given 660 meter, and you have to find speed, the distance by time taken by the sound. 660 by 2, 330 meter per second is your speed of the sound. So, in this manner we can calculate speed of the sound. These points need to remember. Speed of sound in different media. Medium is solid, iron or steel. Okay. Speed of sound is 5000 meter per second. In liquid water 1500 meter per second. Gas, air 330 meter per second. So this is the different media, children. Sound travel faster in liquid than in gases. Speed of sound in water is nearly 1500 meter per second, while in air is nearly 330 meter per second. So sound travels much faster in solid than in liquid or gas. So most sound travel faster in solid. This need to remember. Okay. Next class, reflection of sound we will understand. Okay. Till then, revise, children. Properly revise.